Welcome to Teddy Physics. Define the principal focus of a concave mirror. So concave mirror means it's a spherical mirror whose inner hollow surface is a reflecting surface. Okay. So I'm going to draw a spherical mirror whose inner hollow surface is a reflecting surface. This one is a reflecting surface. Outside we are having silver coating here. So it won't reflect. So why we are calling this one as a spherical mirror means because if you extend these lines, it conforms a sphere here. And since it is a sphere, you can think it's a ball structure, three-dimensional structure. So it is having center, right? So let me take this is the center of the sphere. And the center of this spherical mirror, so this mirror, the center of this spherical mirror, we can call it as a pole here. This is pole. So the line which is passing through the center of curvature and the pole of a spherical mirror is called its principal axis. So this is the pole of a spherical mirror and the center of curvature is nothing but the center of the sphere. Okay. So the line which is passing through these 2 points, we can call it as principal axis. So this one we will call it as principal axis. Principal axis. Okay. So now what we are going to see is how we will take an object. So let me take an object here. So this is an object. I'm going to take a candle here. Okay. So how candle will produce light? So it will produce light in all directions. In all directions. So luminous source. Candle is a luminous source. It will produce light in all directions. For example, if it's not a luminous source, it's a non-luminous source, like a pen, like that. We'll take, if you take like that, a human body like that. So will it produce light in all directions? It won't produce light in all directions, but it will reflect. So the luminous source will produce light in all directions. This will reflect the light in all directions. The sunlight which falls in it. So let me take this as a hit point. Let me take this point as A. So this point reflects the light in all directions like this. Since here irregular reflection takes place. Sorry. Since here irregular reflection takes place, it will reflect light in all directions. Okay. Now let's see this one very clearly. Then you can understand a point here. This is point A and this is point. Let me take this pen here. So it is reflecting light in all directions. So this is one light ray and this is another light ray and this is another light ray and this is another light ray. Okay. So now I am going to consider these 2 light rays here. Here you are seeing these 2 light rays. I want to consider these 2 light rays only. So what happens? For example, initially if you see here, these 2 are separated by certain angle, theta. You can see that they are different. This one ray is going like this, one ray is going like this. You can see it. But when they travel, after some time, what will happen? So the light ray, when they travel after some time, it will look like in a different scenario. So that's what I'm going to draw here. It will look like in a different scenario, a completely different scenario. Okay. So this is the first line, and let me draw you the second line also. So this is the second line here. Second line here. Now if you see here you can find this somewhat theta angle is there like that. But if you see here at this part, if you see here these 2 lines. So this is not the line ma. At this part, these two lines, if you see here, they are almost parallel. Here this part. So almost parallel rays. That means what? When the light rays travel long distances, this small theta angle, very small. Here, for you to observe clearly, I drawn somewhat angle here. Even small theta will be there. A small difference will be there. The time exactly parallel rays like that we can observe. Okay, the light rays will travel after some time. After some distance, we can see those light rays will be exactly parallel rays like that. That's how parallel rays will come into existence from a source. So here we are going to take a source at infinity. Infinity means what? Like for example, take the source as a sun. The sun is at a very long distance, right? So we'll take sun is at infinity distance, like that we will take. So object is at infinity means we can take sun, not a problem. So then the light rays, how the light rays will come from the sun? So sun emits light rays in all directions. We already seen it produces lights because it's a luminous source. So but I am not going to take all the light rays here. What rays I am going to take is the light rays which are parallel to principal focus only I will take. So the light rays which are parallel to principal focus. So this is the principal focus, right? So to this principal focus, one light ray is coming like this from the object now. From the object, where is our object? Infinity distance. That's why I'm not drawing that object. So let me take the object is at infinity. The light rays which are coming here. So they are parallel. So exactly they are parallel. So these rays are parallel to the principal axis. This one is also parallel, and these two is parallel to this one. So parallel to principal axis. How many rays will come like this? There's so many rays will come. Okay, infinite rays we can draw like that. It's not a problem because it is about reducing theta. Okay, how much theta you are taking, that's all. So when they met this mirror here, what will happen now? What will happen? So because it's a converging mirror, so it converges the light rays. Converges the light rays means these light rays will meet. So after reflection, these light rays will come like this, and they meet at a point. So this point we can call it as this point we can call it as principal focus. This point we can call it as focus or principal focus. So this is a concave mirror. So concave mirror, and concave mirror principal focus is this one. Okay. So do you want to know how this exactly, why this is converging? If you want to know why this is converging, I will explain that one also. For example, this is a concave mirror, okay, so which is having a silver coating outside like this. I am going to complete this sphere because how this concave mirror means is a spherical mirror. I mean in this sphere we are going to cut the sphere into parts. So this part, if outer is silver coated, inside is reflecting, means we can say it is a concave mirror. So concave. So outer side silver coating. Silver coating blocks light. It won't allow the light to pass through it. Inside reflections will be there. Okay. Now for example, here I am going to draw the principal focus also. Principal focus, everything. For example, parallel light ray. So this is a parallel light ray, parallel to principal focus. So light ray came and it just hit the mirror like this. So what will happen now? So this is the center of curvature, right? From the center of curvature, we should draw a normal here. So this is the normal. I'm going to draw the normal here. Okay. I'm going to draw the normal here. This is the normal here. Okay. So if this is the normal, what is the angle of incidence here? So this is the angle of incidence, because incident ray to the normal, incidence ray to the normal. Okay, incidence, angle of incidence. And according to the laws of reflection, angle of incidence must be equal to angle of reflection. Angle of reflection means this light ray has to come this side or this side. For example, if this light ray will go this side, how this angle will be, I mean, for normal only we are going to take. So this will be angle of reflection. How this angle of reflection will be equal to angle of incidence? No, right? It won't become. So according to the laws of reflection, if a plane mirror also you may take, not a problem. Whatever it is, here, an incident ray strikes a mirror. After striking a mirror, this is the point of incidence. This ray leaves the mirror like this. And here we are going to draw the normal here. And so this is an incident ray and this is a reflected ray, and the angle between normal and incident ray is angle of incidence, and the angle between normal to the reflected ray is angle of reflection. So this is it. So I am going to apply the same concept here. So here I am going to draw the normal. Sir, how you know this is the normal, sir? Yes, because here this is the center. From center, the radius to any point in the circle, definitely it is a perpendicular only. So radius is perpendicular. Okay, so we can draw the perpendicular to the point here. And so this is the incident ray which is coming here. That is incident ray, and the angle between incident ray to the normal is angle of incidence. So the must and should, the ray has to bend like this only. Why? If it bends like this, then here we will get the angle of reflection, because this is a reflected ray, and according to the laws of reflection, angle I is equal to angle R. Remember, laws of reflection are applied to all reflecting surfaces, not only for plane mirror. Okay, so that is why this ray will bend here. If you want, you can apply the same concept to convex mirror also. You can get the same result only. Thank you for watching. If you want to encourage my work, please subscribe my channel.